Whenever you connect to a computer on a private network through a web interface, chances are the web browser you're using is complaining that the connection's not secure. Now, that's not surprising really, because the certificate of identity that the server's presenting is actually a self-signed certificate. In other words, it's a certificate that the server itself actually signed. Now, the problem is the web browser is only going to be trusting certificates that have been signed by a trusted authority. So these are certificate authorities out there on the public internet, and they don't know anything about your private network. So it stands to reason that your web browser is not going to trust these internal servers. Now, you could actually just ignore the warning. I mean, web browsers still let you do that at the moment. The only problem is it's a bit of a bad habit to actually adopt, because what you're going to run into is the potential that you could end up with a man-in-the-middle attack, and you may not specifically notice it. Because yes, you're just going to ignore the warning, but you're going to still get this other error message up at the top still saying that the connection's not secure. In other words, the actual certificate's not valid. What you really want is to be seeing on your web browser is a secure connection, a connection that your web browser actually does trust the server at the other end of the link. And the problem is, well, if you're just accepting this private certificate and you're always accepting this situation where you've actually got an untrusted certificate, you may not actually know when something goes wrong. On the other hand, if you always have an actual secure connection, you're going to notice pretty soon enough when something does actually go wrong. Now, there are different ways in which you can actually deal with this, but one of those is to actually create your own certificate authority. Now, if that's something you're interested in learning, well, stick around and watch this video, because that's what we'll be going over. Now, to make life easier, I'm putting in a timeline for this video. I'm thinking of the now in the sense that not everybody wants to know everything. There'll be certain sections, maybe people are sticky on certain parts of the actual implementation, in which case it's useful to have that timeline. But I'm also thinking ahead in the sense that it's highly unlikely, unless you're working for a big organization, that you're going to be creating certificates on a daily basis. So chances are you might want to keep coming back to the video just specifically for that section about how to actually create a certificate, how do I sign a certificate, and so on. In which case it's useful to have those individual sections. So hopefully that does help. So this is the problem that I was referring to in the intro, where we've actually got a warning message on our web browser. So I'm actually connected into a VMware ESXi hypervisor. Now, it is an actual secure connection in the sense that the actual connection is encrypted, because if I dig a bit deeper, it's saying HTTPS, but you can see that's been struck out and it's actually giving us a warning message. So this server's got a self-signed certificate, and we've just basically ignored the warning, because that's all you're doing. The web browser is not just, okay, fair enough, we'll accept it's genuine. It's not, it's just basically ignoring the fact that there was a warning there in the first place, because that's your choice. You're just saying, yeah, okay, I accept that there's an issue here and I'm going to accept it. But it's still going to warn you that the connection's not secure. So even if I am genuinely connected to the server esxi.templab.lan, and even if the connection between my computer and this server is actually being encrypted, from the web browser's perspective, it can't guarantee that. It cannot guarantee that this server is what it says it is, because it can't trust the certificate. When the web browser gets supplied in the operating system and through a series of updates, it's got basically a list of certificate authorities out there on the internet that it trusts. And the certificate that came from this specific server isn't on that list of trusted authorities. So for that reason, it doesn't trust the certificate, in which case it cannot guarantee to me that this server is genuinely the server it says it is. Now, from my perspective, I'm 100% certain I am connected to that actual server. But the problem is, from the web browser's point of view, well, it doesn't know. It cannot guarantee that. And that's why it's going to continue to warn me that this is not secure. Now, on the public internet, this is something you'd never want to see, because there's always the potential that the actual connection's been intercepted. And if you're putting in user details like a username and a password, there's always the potential you are connecting to a server that isn't genuine, or your connection's being intercepted. So your traffic is going from your computer to some other computer, which is then relaying it on to the genuine server. And you would actually see something like that as a result. So this, for that reason, is a very bad habit to actually get into, because what you really want to be seeing here is a padlock. You want to see this as a genuine, trusted connection. That way, if something were to go wrong, whether it's a man-in-the-middle attack, whether it's a case of the server's being kicked off the network and someone's put their own in, all of a sudden that padlock will disappear. And you'll see this warning up here saying, this is not a secure connection. And that's what you need to be vigilant about, especially on the public network. But for that same reason, I find it's better to get into that same habit within your own internal network, because this to me is a bad habit, even on your own network. If you're going to keep accepting these, if something were to get compromised and you're just casually accepting these warnings all the time, you don't know if something's actually gone wrong. So it's better that we actually do have a genuine connection, one that is trusted by the web browser and you. And so for that reason, you want a certificate authority. I mean, unless you're actually on the actual public network. So for example, if you're on the internet, you've got your own public domain and so on, you can actually get certificates for your internal network, but you have to have a public presence. Now, I don't want to expose my internal computers out to the public internet. That to me is just a very, very bad security practice. There's no genuine reason for me to actually present any of my computers to the internet. So for that reason, I can't go down this path of getting a certificate from a public certificate authority that the web browser already actually accepts. What I've got to do is to create my own certificate authority. There are different ways to do that. You could, for example, use a NAS. There's quite a few of them out there that actually give you that option to run a certificate authority on the NAS. My only concern is, given what's happened over the years, where some of these have actually been hacked, if you will, and have ended up where somebody's ended up with ransomware problems and all sorts. I don't want to go down that risk, because if the NAS gets intercepted, next thing I know, they've got access to the actual certificate authority. It's similar with the actual firewall, for example. There are firewalls out there that offer multiple services, but I prefer to have a firewall that is just a firewall. If the firewall isn't actually presenting a service, then it doesn't actually accept traffic directly to itself. It's just effectively a relay there to manage the traffic going in and out of the network, but it itself can't be an actual target for a service. So in which case it reduces the attack vector on your firewall. So for that reason, I like to have everything separated out. Somewhere down the line, I'll be getting into containers and so on. But for now, I want individual computers doing their own individual thing. So if one computer gets compromised, I don't have this knock-on effect where all of a sudden there is more services that I'm running are at risk. So the plan is we're going to be using OpenSSL. So that's basically, it's an application used for signing certificates. You can set it up to actually sign certificates as a certificate authority. So that's going to be our strategy. Now, rather than just jump straight into any implementation, I thought I'd give you a bit of a background on how this whole certificate process works. So typically out of the box, you've got an operating system running on your computer, which trusts certificate authority servers that are out there on the internet. So the idea is any certificate that's been signed by one of these computers, your computer trusts. The only thing is, you've also got web browsers on your computer. They've got a separate store. So it's a case of those web browsers, they trust certain certificate authority servers out there on the public internet. Now, when it comes to internal certificate authority servers, that's something you've got to bear in mind. Because if you want to connect to a computer on your network with your web browser, it's the web browser you need to update. If you update the operating system, it's not going to have any impact or benefit for your web browser. So it's just something to bear in mind. But anyway, the way this all works is, out of the box, that's what you're trusting, certain certificate authority servers. So for example, let's say we've got a root certificate server out there on the internet that we trust. So like this one here. Let's say we create a certificate request for our firewall, and we get it signed by this root certificate authority server. That's actual certificates being signed by a trusted authority, a server that our computer, or more specifically our web browser, trusts. So when we connect to this web browser, it's going to present a certificate that's been signed by this root certificate authority, which we trust, in which case the web browser is going to tell us it's a secure connection. Now, that's not really practical. So for that reason, it typically will hand off the responsibility of signing certificates to actual third parties. So you have an extra tree branch, if you will. This is the root right at the start. Then you've got all these branches coming out for sub-certificate authorities or intermediary certificate authorities, so typically third parties. So the idea is a sub-certificate authority server generates a certificate request, which is signed by the root certificate authority. So this server then has its own signed certificate. Our firewall, for example, will generate its certificate request, but instead of getting it signed by the root server, it gets signed by the sub server. Now, it then has a signed certificate, which has been signed by an intermediary. Our computer is trusting the root though, so we have to set up what is called a chain of trust. So for that reason, what happens is the actual firewall here, for instance, it presents its own certificate that's been signed by the sub-server, but it also presents the actual certificate belonging to the sub-server. So this is the intermediate certificate. And then that gives us our trust chain, if you will, because our computer trusts this root server. So what it sees is a certificate that's been provided by this firewall, and it shows that it's been signed by this server. It then sees a certificate coming from the firewall that's been, well, belongs to the server here, and that's been signed by this server. Because our computer trusts this server, it then trusts this server, and so it trusts this server. So that's our certificate chain, if you will. But it's something to bear in mind is you can't just take a certificate from this server, put it on your computer, and then start getting certificates signed by that sub-server. It's not going to work because your computer knows nothing about this server until you tell it. So it's an extra step, but that's typically the process in which it works. Whenever you go to a third party, typically not one of the big major root certificate authorities out there, typically they'll give you the actual certificate for your computer plus their own server certificate, which is backed up by a root certificate. So that's the reason why you sometimes get more than just one certificate to present. But it's a fairly straightforward process, but it all hinges on this one specific server being trusted. So it's something to bear in mind. You've got to guard the private key on this thing with your life, basically, because if this thing gets compromised, it's pretty much game over, especially if it's on the public internet. The chances of getting out of that would be pretty much slim to non-existent. There's going to be so many servers out there, and it's just going to be a big mess. So they've got to be really, really careful, as do you. So not surprisingly, the model does work, and it's a case of, well, pretty much even on an internal network, whether it's a private network, a company network, a home network, whatever it is, that model tends to be replicated. So you build a root certificate server, and then you build a sub-certificate server, and then off you go with your chain of certificates. But there's a bit of a fly in the ointment. Now, while you can still follow this same model of having a root certificate server and a sub-certificate server, personally, I just don't see any benefit to it anymore, especially on a network like this scale. I mean, if you're on a small network, a private network, whether it's a home network, a lab, or a company network, I just don't personally see any benefit to it anymore. The reason being, well, it's twofold. If we go back to when this all kind of started, really, the idea was this would be a physical computer. So it would be built in complete isolation. It would never be connected to the network, meaning it'd be highly unlikely that you could ever compromise it during the build process. So nobody would be able to get access to the key. You'd normally be using CDs to basically keep a copy of the actual private key. When it came to actually signing the certificate for this server, put it onto a CD, pass it to this server, sign it, pass the signed certificate back to that key through a CD. You'd stay away from USB drives because they can be infected with malware through their firmware, for example. But it's very, very secure doing it that way. And then once you've got your actual sub-CA server up and running, you then actually archive this server. So it wasn't present on the network during its build, and it's nowhere to be seen during day-to-day operation. I mean, the actual key's somewhere on a CD in a safety deposit box somewhere. There's probably a copy of 2 copies of it for safety. But this server never comes back unless you have to build more servers, for example. Typically, that would have something like an expiry of 20 years, for example, This has got an expiry of maybe 10 years, for example. The servers have got an expiry of maybe 1 year, but it's highly unlikely you'd ever see this server come back. So it made a lot of sense back then, but now we're into virtualization, which kind of changes the security a bit. So for that reason, when I do build a root certificate server, I've got to be a bit careful. I've still got to build a virtual machine. What I could do, for example, is I could build this server without a network card, install the operating system, I could install UFW, which is the software firewall, and then I can bring it into the network, so that way it's safe. I do need to put it on the network in order to transfer, certificates backwards and forwards between these two, but that's pretty much about it. So I could still archive that one, I could still do it that way. But I now call into question why we even want this anymore, because something else has changed, and that's to do with certificate revocation. Now, another good feature that came with this model was certificate revocation. So that is where we actually revoke certificates that are no longer valid. Now, normally what happens is the server here, for example, signs a certificate for the firewall, and it's got an expiry date on it. The firewall then hands it over to the client, and it's up to the client to actually check, is that certificate still valid? In other words, has the expiry date passed? If it hasn't, then it's still valid, in which case we still carry on with the connection. Now, the only thing is that if this computer gets compromised, then somebody else can actually present that same certificate and key. On the other hand, it might be a case of maybe this computer just needs decommissioning. Either way, we actually want to revoke that certificate from being used anymore. So what we had, and still after that matter, are certificate revocation lists. Now, the idea there is that on our computer here, our subCA server, we actually revoke a certificate. So for example, this one, we've signed this certificate, but now we've decided that certificate's no longer valid. So we tell OpenSSL to revoke the certificate, and it creates or appends onto a list of revoked certificates that it's got. The signed certificates that get created contain details telling the web browser, in this case, where to go and check for revoked certificates. So what the computer does, it's actually a two-step process, really. It's checking if the certificate is actually still valid as far as the expiry goes, but it's also going off and checking this revocation list to see if the certificate has been revoked. Now, if it's not on the list, it's still valid, so it can carry on with the connection. On the other hand, if it's in the list, it's been revoked, in which case it's no longer a valid certificate, and it's going to warn you of such. So that made a lot of sense, but the problem is things have actually changed since then, and what I'm finding in particular is that these vendors, the browsers in particular, that just don't pay any attention to certificate revocation anymore. Out of box, at least, they don't. So the problem I've got is there's different methods you can introduce for this. There's CRL, certificate revocation lists. You've got OCSP, online certificate status protocol. There's also an extra element to that, which is OCSP stabling. But either way, out of the box, these browsers, they're just not interested. So even if I introduced something like that into the network, the problem is the browser is just going to ignore it. Now, you've got browsers like Firefox, and you've also got Google Chrome, for example, which they will allow you to add that feature back in again. Except what I'm finding is that the Brave browser I use and I prefer doesn't let me do that. There isn't a little tick box anywhere that I've found to tell me to still carry on, doing actual certificate revocation checks. So the problem is that even if I introduce that system, the web browser is just going to ignore it anyway. So it kind of seems pointless. Another challenge that was thrown up against these systems is the fact that what the web browser does is it actually fails open when it comes to that step in the process. I mean, aside from the fact that it actually takes longer, I mean, it might take as long as, quite a while. I can't remember the exact time, but it was going to take quite a while for your computer to actually go off and check if a certificate's been revoked, especially if the list gets longer and longer and longer. The problem you've got is the web browser, if it's going to fail open, all it needs is the hacker to block your access to the actual certificate authority or the OCSP responder or whatever, and your browser is going to find that, well, I can't actually go and check if the certificate's been revoked. Eventually it'll time out, and it'll just carry on as if the certificate was valid. So there are ways around it. So it seems kind of pointless now, which kind of makes sense as to why the vendors have just given up on it, basically. So you can implement it if you want, but to me, because of that web browser I'm using, it's just not interesting. And on the scale of things, for me, it kind of makes it pointless to have this sub-certificate authority server, because that was part of the incentive, because if this server was offline, nobody could get access to the actual private key. So if this server got compromised, I could bring this one back, revoke the certificate for this one, build a new server, and then off we go creating new certificates for our servers. But it's like, it seems a bit of a headache to do that. To me, it seems easy to just forget about the sub-certificate server and just stick with one root certificate server. The idea then is, if this certificate server does get compromised in some way, what I'll do is I'll just remove the trust in that specific certificate on that machine. Because at the moment, I've just got one computer that's having to manage all of these computers. So all I've got to do is take away that certificate on that specific server, build a completely new root certificate authority, and then just go back through the whole process. Either way, I would have had to build a completely new sub-certificate server anyway. I would have had to bring this server back into life. So that extra process just seems too much to be justified in doing that sort of thing. Even on a small company network, and if you've got 10 people, maybe it's a case of you just got to go to 10 computers and to update, or even one jump server, for example, and get the browser for every individual user updated. You're still going to have to update all those server certificates no matter what. So it's, yeah, I just don't see much point for it now. It was a good idea at the time, but I think it's had its days, really. So for that reason, my strategy is I just want to build that one root certificate server. So the plan is, we'll spin this computer up. I'm putting it in the build server to keep it isolated. I mean, I've got an Apache server down here. That's not going to be present on the network at the time we build this, so I can still make this secure. Once it's ready to go, then we can bring this one into play, because I want to do some testing. I just want to demonstrate how the certificates work. The idea is I've got access from this specific machine into this network, so I'll be able to get access to that computer through its web browser, and I can get access to that computer through SSH. So that way I can do my copying and pasting, like create my certificates and so on. And we can actually test that our certificates are working, that we've got that trust in place. That just makes it easy, because what I'll do later down the line, I mean, this is just a one-off server. I'll remove it once I've finished with it. But the plan then is, for me, longer term, is I'll actually move this server over to the management network. It doesn't necessarily need to be on, say, like the infrastructure network. There's nothing needs direct access to that server other than my management server. So I don't see any point of putting it out here if this server is the only one that's going to connect to it anyway. It just seems kind of pointless to me. So it seems a lot more secure putting that server into here. There's nothing's allowed access into the management network. So yeah, that seems the safest strategy. Now, somewhere, if I do get a means to automate that and put a sort of like a web-based front end on it, where we can automate the process of getting servers to actually automate their own certificate signing and so on, they would need access to that certificate server, in which case it would then make sense to put it into that infrastructure network. But for now, I'm just going to basically do it all manually on that one server, in which case for me it makes sense to just put it there. So first thing we need to do is build our root certificate server. Now, I'm not going to go through the actual install process, because all we're going to be doing is installing Ubuntu onto an actual virtual machine. So it's pretty straightforward, especially when it comes to something like ESXi. We just got to tell it what the guest OS is, make sure we point to an ISO image to boot from. In terms of the hardware spec, not a great deal. One processor, 1 gig of memory. I've given it 16 gig of disk storage, and that's just for the sake of 16 gig tends to be typical for even SD cards these days. I mean, if I thin provision it as well, it's going to be taking up even less disk space as well, so it's not really that big of a deal. One thing I will point out is that I've got this attached to a dedicated switch for this build network, so the only device that's got access to this is the Apache virtual machine, but the actual firewall as well has also got a leg in this network. The reason I went for a separate switch is just that it reduces the risk of me actually having another virtual machine that accidentally gets connected to this build network, for example. I mean, it is possible, but it's unlikely, at least while I'm building it. Once I'm finished with it, I'll put it onto the management network anyway, so it's not that big of a deal. But it just gives me that extra security protection, if you will, from other virtual machines ever being able to touch this while we're building it. So we'll then go through the install process, which again, I'll not really cover because it's pretty straightforward. But when it comes up with the option of building the actual drive, it'll actually ask you if you want to enable encryption. And I would recommend you do that because this thing's going to have a private key on it. And we want to actually protect that. If somebody gets a hold of the actual virtual disk image, we don't want them to be able to spin it up on another actual computer and get access to the key. So for that reason, by encrypting the actual hard drive, it means every time this virtual machine spins up, you've actually got to put the actual key in to decrypt it. Then once it's up and running, obviously you'd have to log in to be able to use it and so on. So it's a bit of extra security going into that. The other sort of questions you'll be asked are for a root password, which you'll obviously want to make that long and secure. You'll be asked for a user account. Again, you'll want some obscure user account, for example, something not too obvious. A long security password as well for that, which is different to what you use for the root. And then it's a case of, it'll also want probably a host name, although we could change that afterwards. You can be a bit more like security paranoid, I suppose, when it comes to building this. I mean, I've got this actually connected to the actual switch. You can actually opt within the settings, for instance, to not connect that. So the interface exists, it's just not connected. You could, for example, not put the IP address in when you actually configure it because the network card won't be there. You could just leave it on DHCP, for example, in which case, for me, it's not going to get an IP address. So even if it does spin up on a network and there's another computer there, there's no IP address to talk to it. There's all sorts of different ways you can be extra secure. But for me, I'm quite happy to have this separate network. There's nothing, the only thing attached to it is the Apache server, which is down, the firewall, which, yeah, okay, the management server could get into this, which it's going to be able to anyway at some point, so I'm not too fussed about that. But I think that's about as far as I'll go in terms of that aspect of the security. When it comes to the software to get installed, it does ask you if there's any particular software you want to install. I mean, it does ask you, for example, if you want OpenSSH, or at least Ubuntu does. And I will opt to get that installed because I want remote management into it so I can do my copying and pasting. But any other software I'm going to deselect. Now, by default, it asks if you want to install standard utilities. Now, I don't need those, so I'll deliberately deselect them. The less things that are on this machine, the better, really. So the idea is I'll spin up as just a bog standard Ubuntu server. It'll have OpenSSH on it so I can remote into it. And then we'll just install, well, we won't install anything really other than to update the software after that and just run your basic OpenSSL. Basically, everything else is already on as we need it. So I'm just going to get on with building this machine, and then once it's ready, I'll bring you back. So we've now got Ubuntu installed on the computer, and what I've actually done is to install the updates on the computer as well. So we're now pretty much ready to go. But before we actually start delving into OpenSSL and how to start creating certificates, signing them, and so on, I just need to make one or two changes first just to get things started. So at this moment in time, this is the only computer within the build network, and only the management server can get access to it. But I still want to tighten up the security. So for that reason, I'm going to enable UFW. So that's the actual software firewall that we're going to be using in Linux. Now, the actual user account I've got here is kind of obvious, I must admit, but because there's a video, I just want to keep things nice and simple. But I would suggest coming up with something, slightly obscure, just to confuse people, basically make it harder to be able to log in. Now that UFW is enabled, what it means is that this computer can get access to things, but nothing can get remote access to it. Because if I actually ask it for the status, it shows, yeah, it's active, but there's no rules applied, so there's no inbound access allowed. So I do actually have to make a change to allow the management server to get access to it again. So I'm going to do sudo UFW. Now I'm going to use the limit command which is very useful for SSH because it's going to limit the number of attempts you can get. If I use the allow command, yes, it will allow SSH access, but if you've got some sort of automated program that's constantly trying to log in, whereas with the allow command, it just would keep allowing it to try, the limit command is only going to allow a certain number of attempts, then it's just going to block access from that IP address for a period of time. So it's pretty useful in that respect. So what I need to tell it is what the protocol is. In this case, it's TCP that we're using for SSH. I need to tell it where we're connecting from. So it's 172.16.18.10. I need to tell it where we're connecting to. Now, this particular computer only has one IP address. It's only got one network card, so technically it wouldn't matter if I put in any. But it always pays to be more secure because you never know what's going to happen somewhere down the line. So in which case, I'll put its own IP address in to be more specific. Now, I'm just going to get that window back. One thing I then need to do is tell it the application we're allowing access to. So it's port 22, which is used by SSH. So if I then ask for the status again, yeah, UFW is active, but I'm restricting access now to SSH. So I'm allowing access from the management computer, but I'm also going to limit it. Any other attempts to get access to this computer are going to get blocked. Now, before I now jump across to the management computer, I think while I'm here, I'm just going to make some last minute changes before we actually get started with OpenSSL. So the way this is all going to work is that OpenSSL is an application. It's not running as a service. I need to store information on this computer, things like private keys, certificate requests. And there's no point putting that into some sort of shared area if all I'm going to do is log in as the actual, say admin user in this case, and then just run OpenSSL from that user account. So for that reason, I'm just going to leave everything within the home directory. But I want a nice orderly structure where we keep things just to make my life easier. So I'm going to actually make some folders. I'm going to do make dir. I'm going to use the -p parameter within there, which basically says that if I specify a folder in here, which is a parent folder, and it doesn't exist, well, create it. So the reason I'm doing this is it just means I can create a folder and a series of subfolders in one line. So it makes life a bit easier, really. So I want to call that folder CA because it's a certificate authority we're going to create. And then I want to create some subfolders. So that's the reason why I want the -p, because if I try to run this command without the -p, it's just going to bark because, well, the CA folder doesn't exist. Right, I want a folder called private, which is where we'll store private keys. I want a folder called certs, which is where we'll store signed certificates. I want another folder called new certs, which is where OpenSSL stores certificates. So we'll be outputting to certain, when we actually run this OpenSSL command, we'll tell it to send the output of the signed certificate to our certs folder, but it'll actually create a backup in that new certs folder for us. I do also want another folder called CSR, and that's going to be for our certificate signing requests. Now, part of the reason for doing that is with some of the actual applications and systems that are out there, I can actually do everything on this computer. I can create a private certificate, I can create a certificate signing request, I can then run OpenSSL to then generate a signed certificate, and then all I've got to do is effectively paste the contents of the private key as well as the actual signed certificate back to that application, for example. So it makes sense to be able to keep everything on that computer. Another option is, well, at some point certificates do actually expire. Now, the actual signing request doesn't really change. It's always pretty much the same. So what I can do is by keeping the signing requests on here, even if I do have to generate a signing request on another computer, I can upload it to here, keep a copy of that, and then when I need to create a new signed certificate, I've got the actual request already ready to go. So it makes life easier both now and further down the line. So that creates our folder CA plus all the subfolders. So if I do ls-l, unfortunately for some reason the console that we've got gives you, directories in kind of a dark shade of a blue, so they're a bit difficult to read. But if I have a look in that actual folder itself, there are now 4 subfolders, so it's created everything for us, which is great. The only problem we've got is that a private folder, which is where we're storing private keys, it's allowing read access, for example, to that folder to the other group, which is, well, it's not really a good idea, because that's all you need basically. If you've got read access of a private key, then, well, yeah, it gives you a bit of an advantage that you shouldn't have. So we don't want that. We don't want anybody other than this CA admin user getting access to that folder. So for that reason, I'm going to make a slight change to the permissions. Do it in verbose so that you can see the output. Now, basically that number, there's different ways, you can do this, but I'm doing it with the numbered approach, which basically means 7 is basically everything, 0 means nothing. So what we're doing here is we're actually going to assign the owner all rights, the group no rights, and other, or everyone, no rights. And I want to do that specifically for the private folder. So it comes back and tells us, well, it's changed those rights from 775 to 700 basically, and that's pretty much what we want. So if I go back and ask it, you can see down the left-hand side how the CA admin user, in other words, the user account, the owner of that folder, has got read, write, and execute permission. Everybody else, including the CA admin group, members of it, doesn't have any rights, and that's exactly what I want. Now, when it comes to OpenSSL, it actually keeps track of serial numbers that it assigns to certificates. It also keeps the status of certificates that it's assigned, plus all the actual certificates assigned. It keeps track of all these in sort of databases, if you will. Pretty just flat databases, nothing complicated, just files. So when it comes to the serial number, it just needs to be a number basically, but what we can do is just throw in, say, some hexadecimal number, for example, so that when that serial number goes out, it's not so obvious. So I can actually use the OpenSSL command for that. We'll use the random option in there. I'm going to use hexadecimal, 16 characters, for example, and I'm going to output the result to a file called serial in the CA folder. So it's now created that. We didn't get any feedback as the output was sent to CA-serial. So if I actually ask it, well, what is the contents of that file there that we've created called serial? And you can see it's just one big long hexadecimal number. Now, when we actually run OpenSSL, the way we're going to actually have it configured is that we're going to be telling it to actually go to this file called serial for the next serial number for the next certificate to assign. So it's actually pretty simple, to be honest. It's just going to come to this file, take that number, assign that to the certificate when it gets signed. It's then going to increment this number to a different serial number, and it'll store that in a serial file. So again, it doesn't necessarily have to be hexadecimal, but yeah, we're doing that just for the sake of making things a bit more complicated for anybody trying to guess, some sort of sequencing numbers, for example. Now, one of the file that I need is going to be an index file. So this is basically the index, if you will, or database of the actual certificates that OpenSSL has created, or at least within this folder for us when it's being used. So when we're actually beginning, it doesn't actually need any content, so that's why I'm using the touch command. I'm just saying, basically just create a file called index in the CA folder. So if I actually ask it, well, what's the contents of that file? It comes back as empty. It doesn't need anything in it, because when we run the index file, OpenSSL is actually going to populate it. So that index file is going to keep changing. It's going to get bigger and bigger as more certificates get added. It'll give you details about the certificate that's been assigned, the serial number that's been assigned, what the actual common name is, for example, what the actual status of the actual certificate is, and so on. So there is a bit of a database thing going on here, but that's pretty much it as far as I need to go as far as the initial setup, because now we actually need to get started with actually creating certificates and so on. But the very first thing we need is an actual private key, because we have to actually be able to sign certificates in the first place, and we actually sign them with a private key. Now, we're actually remotely connected into the actual root certificate authority through our actual management computer. One thing I'll actually point out, though, is that I'm actually connecting in through VMware's remote console software. If I just minimize this, I come back to actual ESXi here, when you actually connect in through the console, you've got options. You can either connect to the console through the web browser, or if you click on the console option here, there's another option which is to launch remote console. So that's this VMRC software. The only problem is if you just go in through the browser console, you can't actually copy and paste. Even if you put the actual guest tools installed, you still can't copy and paste into an actual console through the web browser. So for that reason, I've actually downloaded this VMRC software and installed it. But it doesn't actually run. You don't run the application and then start connecting. Instead, you just go to ESXi, pick out the virtual machine you want, then you click on console, and then you click launch remote console. That then launches the actual application, which then gets me a different kind of console session, if you will. So now the good news is I can actually copy and paste into this terminal session. So I've logged in as CA admin into that server. It's the only user I've got on there anyway. But it means I can now copy and paste, and that's very important because the next thing we want to do is to create a private certificate key, for example. There's going to be configuration commands and all sorts we need to put in later on, and copying and pasting is going to be extremely important. So because I've got this software installed on my Linux computer, I can do that now. So the reason we want a private key on this computer is, well, the whole way this cryptography works is it's based on using a private key to sign certificates. So the idea is our root certificate authority is going to have a private key. It's then going to have an actual certificate created. We're then actually going to sign that certificate with our private key, and we'll then trust that certificate. But the key factor here is you need a key to sign the certificate in the first place. Now, once the computers out there trust that certificate, they'll then trust any other certificate we create and sign on this computer using its private key. So the private key is very, very important. You don't want to lose it, and you don't want anybody being able to compromise it. So this particular computer that I've built, the hard drive is encrypted. So it's a case of, even if you can get a hold of this hard drive itself, you're going to struggle to be able to decrypt the contents. But even if you could, I'm going to go one step further, and I'm actually going to protect the actual key that I create. So that not just protects it while the actual computer's at rest, but also while it's actually up and running. If somebody could actually somehow get access into this computer, or if somehow the actual key got off this computer and went somewhere else by accident, it'd be a case of you'd need a passphrase to be able to use the key. So for that reason, I am going to copy this command from my computer that I've connected into on this management computer here, which we're then using to SSH into this CA server. I'm just going to right click in here, paste, and we've now got our little command here. So basically what we're telling it to do is to run the OpenSSL command. Now, one thing I'll point out is I'm in the CA folder actually. And if I go to ls-l, these folders do show up a lot better than they did when I was connected into the console of the actual server itself. They're in a lighter shade of blue, which is a lot better. But I'm connected into this specific folder because everything that OpenSSL is going to be referencing is going to be found in this folder. So it makes sense to actually, park yourself here. So I've switched over to that folder, and every time I want to use the OpenSSL command, I'll just switch into this folder. So again, just do a quick paste. So to create the actual private key, we run the OpenSSL command, and we're telling it to use the RSA algorithm, so gen and RSA. So we're telling it to basically generate a key using the RSA algorithm. Now over here we've got an option -AES 256. So we're using the AES algorithm, 256 bits, and we're using that to actually secure the actual key. Now the key itself, we're actually telling OpenSSL to send the output to our private folder and to an actual file which we'll call root-ca.key. By putting this parameter in here, this AES-256 here, what it'll actually do is it'll send the output, it'll create this file, and it'll actually protect it with an actual passphrase. When I hit return, it's going to actually prompt me for a passphrase, and it'll then ask me to confirm that passphrase. And what it'll mean is we'll end up with a file which, if we actually want to use that key going forward, every time we want to sign a certificate, it's going to prompt us for that same passphrase. So it's a passphrase we want to know to be able to use again. So it's a case of, this protects the actual key itself. Even if somebody does manage to get access to it, you can't use it unless you know what the passphrase is. And to be extra safe, we're ramping up the actual size of the actual key that we're creating to 4096 bits. Now, on a server, a key size like that, at the moment, doesn't usually make all that much sense. Typically, you'll find them to be about 2048 bits, because the idea is that a server is going to be regularly using its key and to be able to sign things, encrypt and decrypt traffic. So on a server, it doesn't really make sense to have a very, very big key size, because it requires much more processing power. This type of key that we're creating is just being used to sign certificates, on the other hand. So it's only going to get used every time we need to actually create a certificate. So it's not that big of a deal about the actual size of the key. So it makes sense to make it a big key size. So I'm just going to hit return. Off it goes and creates the key. So it says there it's generating an RSA private key. Now it's now prompting me for a passphrase. So that was just went through a process of generating random numbers. I'm going to put in a passphrase. Now, what I would suggest is to make this a very long passphrase. Put it into an actual password database and keep that very secure. That makes it much, much harder. Because this is a video, I'm more prone to making mistakes here, in which case I want to try and keep this as simple as possible for me. But in a real production environment, even in an actual training lab, even on your own home network, it still makes sense to use very, very strong passwords, basically. So I'm just going to hit return, and now it wants me to enter that same passphrase again just to confirm it. Okay, so fortunately I did actually type the right one twice. So I've now actually got a key. So if I have a look in that folder, I won't want to be using slash because it's not the root. So you can see it's actually created a key. It's called root-ca.key. You can call it whatever you like. It's entirely up to you. But because it went into that private folder, only CA admin has access to that actual file. And that's because we set up the actual permissions early on to actually restrict who can get access to this folder. So this makes a lot of sense. I mean, we're being very, very careful in terms of security. In the sense it's, the hard drive's encrypted, the file's also being protected by an actual passphrase. So the downside that I've got is every time I want to actually generate this certificate, whether it's a certificate for a server, whether it's going to be a certificate for itself, I have to remember what that passphrase is. I have to be able to put it in. I'm always going to be prompted with all these commands, but it is well worth it for the security, because everything hinges on trusting this one computer. If this computer gets compromised, yeah, it all comes down like a pack of cards. But the good thing is we now actually have an actual private key we can use to now start signing certificates. Now the next thing we need to do is to actually start generating our own certificate request, which we'll then sign. But before I even do that, the next thing I actually want to do is to create a configuration file that this computer will be using as an actual certificate authority. There's a lot of parameters go into running that OpenSSL command, and life is a lot easier if you put most of that into an actual configuration file. It makes the whole process, there's far less information you've got to put into the actual command itself. You just reference it back to the configuration file. So what I'm going to have to do is get my actual config file and then paste it onto this computer, and then what I'm going to have to do is actually use that to actually then start creating things like generating the certificate requests we want, to be able to sign certificate requests as well to generate the actual certificates. Now I've made the screen a bit bigger, hopefully you can see a bit better, but what I've got here is a configuration file for our root certificate authority. The idea is that we can actually run the actual OpenSSL command, and we'll be able to reference back to this configuration file rather than having to keep putting lots and lots of information into it. So there's a lot to cover, I must admit, in here, but I'll touch upon certain things that are particularly important, at least the ones that I feel are anyway. So whenever you actually use OpenSSL as a certificate authority, it's always going to reference this. That's what this CA bit means. You run the actual OpenSSL command and you put in the parameter CA, and that's when you're referencing this config file, that's what it knows. Ah, yeah, you want details about the certificate authority. And then in that particular section, as you can see, it's then referencing another section, which is CA-underscore default. So this contains various things like the directories. So that's basically the root of the folder that we're in, if you will. In our case, it's actually the CA folder. So it's telling it certificates go in the certs folder, new certificates and new certs. The database is a file called index. Your serial file is called serial. We've also got this entry here, which is rand file. This is basically an actual random file, or rather, this is where the actual computer is going to generate random numbers that it uses for its cryptography purposes. So we're actually going to get it to work on this file every time it's generating random numbers and so on. It needs a file to be able to store all that sort of information in. So that's what we've got this line in here for. Then down here, we're telling it what the certificate is, what the private key is. So these are the ones we're going to create. I mean, we've already created our root-ca.key. We're yet to create the actual certificate itself, but we'll be using this configuration file to do it. Hence why I've created the actual config file first. Pretty much all of the things we're going to be doing is going to involve SHA-256. That's why I'm using that. Default days, 365. Typically, because of the way I'm working, is I'm going to be mostly generating server certificates. We don't have two layers, if you will, of certificate authorities. So I'm just going to be creating mostly server certificates, which are going to last 365 days. So I don't have to actually reference that when I actually create certificates. I can just reference it to the config file, and it knows that the actual expiry is going to be in 365 days time. We then have what's referred to lower down as this distinguished name here. So these are all the details about the actual company and the computer itself, but this all gets referenced further up here by what's referred to as the policy, and it's actually asking what is the policy that you're operating. So we're referencing a section called policy_strict because this is a strict policy that we want. We want the country name to be supplied. We want the state or province name to be supplied. The organization name has to match our actual organization name that we're actually using with this certificate. So when we create this certificate, we'll actually give it a particular name, and we actually want to use that same one for all of the certificates we create going forward. Now, the thing what you can do is, I mean, this is all entirely up to you as to what you do, but for me, all of this is all within one local network, so this makes a lot of sense. Now, if on the other hand you're working in a company and you're going to have offices in different countries, for example, different departments, different branches, you'll probably want to change these and make them a bit more loose, if you will. So you may not necessarily want the organization name to match because you might have multiple companies within that main company. So, it's entirely up to you. But in my case, it's just a lab, so I'm just going to do that. We then get into an organizational unit name, which for me, it's not that important. So I'm just leaving that as set as optional. You don't have to put that in. You will be prompted, but it's up to you whether you supply it. The common name is, well, we don't necessarily know what the actual name of the computer is in advance. So for that reason, we're just going to say that it's supplied. It is a very important name because this is, for a server, for example, this is the fully qualified domain name, like, www.microsoft.com. That's what's referred to in the certificate as the common name. The idea is that when you actually connect to the actual computer, you connect to it through its domain name, and that's what the certificate's got to align to. Most of the time, you can use IP addresses, but most of the time you'd be expecting to connect through the domain name. And then the email address, again, I'm leaving that as optional. Now, all this information is important to the actual company that's actually providing the certificate, because they've actually got to vet the requester against the public records. So it's a case of, do you actually own that domain? What are your business credentials? Are you a legitimate business, for example? So that's what all this information is for. It's not just specifically for the server. It's a case of, does this server actually exist? Who does the server belong to? Is the person requesting the certificate the actual owner? All of those are important things to go into this actual certificate request. So that's very, very important for that reason, because everything's based on trust. You're trusting the certificate authority server, and you're relying on them to actually vet the people who are actually requesting these certificates that ultimately you're going to be, connecting to their servers with. So it's a case of, yeah, this is, it is very, very flexible in terms of what you do. It depends on what you're going to be using the certificate authority for. But for me, I've gone for a relatively strict policy. But that's what that is. It just references basically that, and then that references later on down to this. So this is another section that we've got, which is the REQ. Whenever you actually place a request for a certificate, service certificate, for example, within OpenSSL there'll be an REQ command or parameter. So whenever it sees that, it'll be referencing information on here. So for example, I'm just going to use a default size of 2048 bits. So rather than me having to keep putting that into the command line every time, it's there as the default. Same as the message digest, again, SHA-256. But it does need to reference this distinguished name, which is this block lower down. So what that basically does is, whenever you actually ask it to generate a certificate signing a request, it basically looks into this section here ultimately, and it's saying, well, I want to know what the country name is, and it gives you that. In the left-hand side, what you'll see, I mean, you'll see as we go along, but in the left-hand side, you'll see this information where you'll be prompted for the country name, 2-letter code. Down here, we've got the default settings. So these are applicable to me. So for example, the default country name is going to be GB. The default state or province name will be England. The organizational name by default will be temp lab. That's what I've called it because it's my temporary lab. So you get asked all of these questions. These are the default settings. So the idea is, when it actually asks you about what's the country name, if you don't actually enter anything, then it'll just assume you want it to be GB. Same as the state or province, it'll assume you mean you want to use England. It does actually tell you what the defaults are if you just hit return. So while those sort of options like the organizational unit name and the email address we don't particularly care about, you will still be prompted with them. It's just entirely up to you as to what you provide. But within a real certificate and a real certificate authority, they will want to know what your email address is in case something doesn't work. If they have any problems, they need to know who to actually contact. So that's what the email address is for example. Down here we have another section which is v3_ca. This makes sense when you're actually creating certificates for an actual certificate authority. If I go a bit further up, there'll be a section, if I can find it, where it actually references, there it is there, the X509 extensions. Whenever you're creating these certificates, it wants to, sign it with certain extensions based on X509, which is the system we're using here. So whenever you put in that X509 setting there, it's a case of you've got to tell it what to, what the settings are. So there's all sorts of information you put in. But what I can do is I can just reference it to either this section, for example, if I wanted to create an actual certificate authority certificate. If I want to create a user certificate, I can reference it to this section here. If I want to create a server certificate, I can reference it to this section here. And you can see there's various different settings depending on what it is you actually want to, what type of certificate you want to create. But by default, because most of the things I'm going to be doing is an actual server certificate, I've got the default settings set for server cert, which is this section down here. So I don't particularly tell it which type of certificate we're interested in. It's just going to revert to, issuing a server certificate. But anyway, that gets us our configuration file, which we can now use to generate our own certificate server requests, or any other for that matter, but also to be able to sign certificates as well. So we've now got a private key, and we've got a configuration file that we can reference. So the next thing we actually want to do is to create a self-site certificate, because that's basically what it's, what's at the heart of all this is we're going to have a self-signed certificate, because ultimately there's nobody out there can trust the actual root certificate authority. It's just not possible. You've actually got to trust a self-signed certificate from ultimately the root certificate authority, and then you trust all the certificates that it signs going forward. So the good thing about SSL is we can actually bundle things into one command line. So I'm just going to copy this command, paste that into the command line, and I'll explain what all this means, because basically what we're doing is we're actually creating the certificate signing request, and we're actually signing that certificate signing request to ultimately give us a self-signed certificate all in one line. So we're running the OpenSSL command back here, then we're placing a request. We're then referencing it using the config parameter to our root-ca.conf file that we've just created. Now, because I'm actually going to be creating an actual certificate authority server certificate, and the actual config file is set to, by default, actually set up certificates for servers, I've got to reference it. I've got to tell it to use the extensions v3_ca. So that's what, if you go into that config file, you'll see there's a section called v3_ca, which references certificate authority servers. Now I've actually got to sign this actual certificate signing request. So I'm giving it this -key parameter to point it to the actual private key here. So that's the key that we created earlier, which is in our private folder. I want to create a new certificate here and a new request, and I want to use X509 as part of the process. So in that config file, there's details about X509. By default for us, it's referencing server keys, hence why I've got to have that extensions in there. Another setting I've got to put in as well is the number of days for expiry. Typically with a server, you'll probably have like 365 days. So by default, I'm running the config file with a setting of 365. For an actual certificate authority server, now, if you have a root, you might be using like 20 years or something. For a sub-certificate authority, or in our case, we've just got one server, we're going to go for a bit less, of 10 years. The chance of this thing still being around in 10 years is slim to non-existent, but you can be a bit more flexible. You don't necessarily have to go with that amount. You can put in more if you like, put in less, entirely up to you. Now, the actual final result is the actual certificate itself. This is going to be a self-signed certificate for the certificate authority that we'll be trusting. So for that reason, we need to tell OpenSSL to send the output somewhere. So we've got this -out, otherwise it'll just pop out on the screen basically. And we want to put it into the certs folder, and we're going to call it root-ca.crt. Now, the name at the end is entirely up to you. There's a lot of different names get used out there. The actual format's always the same of this PEM format. So it's entirely up to you what you want to actually call that, but that just happens to be one of the naming conventions that gets used. So I'm going to hit return. Not surprisingly, because we actually protected our actual private key with a passphrase, it's now actually prompting me for the actual passphrase, because we're actually asking this to create a signed certificate with a private key. And because of that, I need the actual passphrase. So I'm going to put in my passphrase. And because we're actually generating this we're generating a certificate signing request, we've got to go through this process of actually answering the questions for the distinguished name, or DN if you will. This is all the information that a business is going to vet the actual requester for. It's all the information that's going to go into the certificate, so that the user who's actually looking at the certificate on the server can actually check if it aligns with what they expect. So like I was saying earlier, it's a case of we've got all this information that we've put in the config file. So for example, we've got the details here saying, oh, country name, 2-letter code, and by default it's giving me GB. So if I just hit return, then this certificate signing request is going to use GB as the country name. I can change it to something else, but in my case that's exactly what I want, so I'm just going to hit return. It then asks for my state or province. So for me, the config file is set to by default England, so I can just accept that if I wanted to, and hit return. It's now asking me for a locality name. Now, I didn't put any details in the actual certificate, or rather in the configuration file, I should say, for this. I didn't give it a default setting. and it's also something that I'm not overly concerned about. So by default, it's just blank. So if I want, I can just hit return and just accept that. For the organization name, we did put a default in there for called temp lab. So in my case, that is what I want. So I'll just hit return. It wants an organizational unit name. Again, I'm not too fussed about that. I didn't set a default setting, so I'm just going to hit return. Now, this is where it gets a bit interesting because it's asking for the common name. So if you connect to a web server, for example, that would be the FQDN. That's the fully qualified domain name that you would typically type into your web browser to connect to the server. You can set these up for IP addressing if you like, but, or at least when it comes to the alternates, I should say, typically though, a certificate, especially these days, is a lot more strict. It really wants you to be using fully qualified domain names. Now, this particular certificate is a bit different in the sense that this is a certificate authority certificate. We're not actually going to be using an FQDN, for example, to connect to this computer. So we don't actually have to have an actual name that lines up with something that we're going to be using. So we can just use something that's a meaningful name if you want, and it doesn't even have to be a fully qualified domain. It could just be a host name, for example. It can be anything you want, as long as it provides some sort of meaning to identify what this certificate is basically for and who it belongs to. So for that reason, I'm just going to call this one root CA. So again, I've got no domain details in there. I'm just calling it root CA because this is my root certificate authority. So I'm just going to hit return. It now wants to know, well, what's your email address? Again, I'm being a bit flexible here. I don't particularly need to know. If you were doing this on an official certificate authority server, that is information you would want to know. But as I say, in my case, I'm not too fussed, so I'm just going to hit return. And that's it. So if we do ls/certs, for example, don't want a slash because that goes to the root. You can see there's now an actual file out there which is called root-ca.crt. So that is actually the actual public certificate that now belongs to this server. This is the certificate that we're actually going to be trusting going forward. I mean, to say the actual, extension can be quite flexible. It's not that important for most systems, I should say. But what I can do is I can actually run another command. Because if I actually just read that, if I do cat certs/, I can just tab that out. That's just gobbledygook. It's just a bunch of random letters and numbers. It doesn't really mean anything to someone like me. I have no idea what that means. But what I can do is I can actually use OpenSSL to actually read that certificate and make it a bit more meaningful. So if I use the command OpenSSL, then I tell it we want to use X509 because that's what we're interested in. This is an X509 certificate. I don't want the actual outputs coming out to for this particular case. It's a case of I don't want to send the results off to an actual specific file, for example. I want to see it on the screen, and I also want it in a text format so it's something that I can actually see, and it makes it a bit more easy to read. And then I actually have to tell it what the actual file is that we're reading in, so I'm referencing that certificate that we've just created. Now if I hit return, it's just gone off the screen. Now fortunately, I can scroll up the screen if I want to. Another option is I can just pipe that out to more, for example, and it'll actually pause it. So what we've got here is it's saying, oh, well, this is a certificate. You can see there, that's the first line. So it's telling us that we've got a certificate. I'm going to scroll down a bit. We're using version 3 for all this process here for the certificate authority stuff. It's giving us a serial number for that certificate. It's telling us that the actual algorithm is SHA-256. Now the issuer of the certificate, so that's the actual certificate authority that signed it. The country was GB, the state or province was England, the organization was TempLab, and the actual common name or FQDN, whatever that would have been, is root CA. So that's exactly what we'd expect. Now the validity of the certificate, which is basically around the actual expiry information, is saying that this particular certificate is valid from this particular day, this particular time, to this particular year, and then that's the expiry. So you can't use it before that time and date, and once you get past this time and date, the certificate will expire. It's not surprisingly, it's 10 years into the future. because that's what I've asked for, an actual 10-year certificate. Now the subject is basically the server details that requested the certificate in the first place. Now in our case, this is a self-signed certificate, so not surprisingly, the subject and the issuer are exactly the same. It's a self-signed certificate. Root CA, which is our computer, created this certificate request and then signed it using its own private key. So that's why those two are exactly the same. When we create server certificates, you'll find that the subject, well, the CN will be the FQDN of the server, but then the issuer of the certificate will be root CA. So I can just hit space. It gives us a bit more information about the X5093 details. This is all this stuff that we've been putting into our config file, for example. One of the key things is that where it says CA equals true, basically. So what it's saying is this certificate is actually a certificate for a certificate authority. On a server, that should be false. We don't want that to be an actual certificate authority certificate. We do not want servers out there spinning up their own certificate authorities or anything. This particular server could, but it's a case of, well, we're only using like, one branch level. This is the root and that's it. But it just means that this could potentially be used to create other certificate authority servers. You can basically create anything. So that's pretty much it. We've now got a private key, so we can sign certificates going forward. But we've also got a public certificate. Now, what we want to be able to do is, well, we want to be able to test this. We need to be able to actually test that our computer will actually even trust this actual certificate. When we sign a server certificate, we even need to be able to create a server certificate to sign in the first place. So that's the next step, is to actually create an actual certificate for a server. Now, if you want to actually give an actual computer or an application an actual certificate that you're going to be able to trust, you have to actually generate a certificate signing request. And to generate an actual certificate signing request, you need a private key. Now, it really depends on the actual application. There's different ways to go about all this. Fortunately, we've got this standard system in place when it comes to creating these keys, which means for a lot of the systems that are out there, we can actually create the private key and the certificate signing request on our actual certificate authority server. And that's especially true in the case of, say, like this Apache server we're going to be testing against. That's just another Ubuntu Linux server. So it's pretty straightforward for me to actually do all this on this server, send all the results to that other server, and then we can test it from there. But again, it varies. So this is just an example of how you can actually do that, using OpenSSL and Linux. So the first thing I've got to do is to actually create the private key for the server in the first place. So I'm going to run this command. I'm just going to copy this command, kind of similar to what we did for setting up the private key for the certificate authority server. We're just being a bit more flexible when it comes to the bit size, because if we make it too big, it's going to put a much bigger load on the actual server. So 2048 seems pretty much the norm these days. What you might notice is that we've still got this gen RSA command here, and we've still got an out parameter to tell it where to send the actual key to. But one thing that's missing is the -AES256 parameter. And that's just because we don't actually want to protect this key with an actual password, because every time we want to use the key, which means every time we want to start the actual server, for example, you'd have to put that password in, which isn't all that practical. So for that reason, we're not going to protect the key. We're actually going to still generate a key, we're just not going to protect it. But it's a case of you still want to guard that key because it's private to the actual server that's going to be serving up content. So pretty straightforward. OpenSSL gen RSA -out. We're outputting to our private folder, and we're going to call this test server.key. We're giving it a bit size of 2048, and that's it. Pretty straightforward. Didn't prompt us for a passphrase because we're not protecting it. Now, when it comes to actually getting certificates for servers, we're not actually creating self-signed certificates. We're going to get a certificate authority to actually sign a certificate for us. So for that reason, we have to generate what's called a certificate signing request. That gets sent over to the actual certificate authority server to then sign and create an actual certificate that the server will use. The only thing is, Google, well, they've introduced a bit of an extra requirement when it comes to certificates that it expects from servers. and that's to do with a subject alternate name, because potentially computers can be presented as multiple different names. You might see it as one FQDN or then another. You might see it as an IP address, and Google wants all of that actually included in the certificate. So it's not like where you can just generate a certificate signing request and that's it with the command. You've actually got to feed it a bit more information to put in the certificate. So to make life easier, we're actually going to create a config name specifically for this first. So what I'm going to do is just do a bit of copying and pasting. So I want to create a file. I'm going to call it testserver-csr.conf. And then I'm going to do some copying and pasting, but I'm going to have to tidy this up. It always ends up a bit messed up depending on the transfer, because these are all tabs basically, and sometimes they end up as being converted from tabs to spaces, so yeah, it can get a bit messy. So basically what it means is that when we create an actual certificate signing request, we're going to actually reference it back to this config file, because ultimately what I want is I want to be able to point my web browser to a computer called test.templab.lan. Ordinarily, until Google enforced this in its web browser, that's pretty much all you needed. But then they threw in this extra requirement for this subject alternate name. So you do have quite a bit of flexibility. You can call it, whatever you like. You can have it. You can have like options for FQDNs. So you can have that. The first one we've got references back to the actual common name. So that's what we've got there as a DNS entry. So if I connect to this computer as with test.templab.lan, that's going to satisfy Google's requirement for an alternate name for it. If I don't put that in, the browser is just going to bargain me. I do have other options. I can put more than one DNS entry. I can also even put in IP addresses, so that's an IP address entry. So I can actually put in its IP address and even reference the server through its IP address. But basically, I'm just putting in some defaults backed out. I'm referencing the section. This section up, this line up here references this part here. This line here for the extensions references this one here. That one in turn is referencing this one back here. But one thing I'm going to mention is the fact that I've got another line in here which says that the prompt is no. In other words, there's no point prompting me for all of this distinguished name information. It's all contained here anyway. So it just saves me a bit of hassle. So I'm just going to save this file. And I left it in the CSR folder, because what we'll find out is that when I actually create the test certificate, or rather the test service certificate, I actually have to reference back to this file. So even though the information for this subject alternate name has actually been put into this certificates request, it doesn't get carried over to the certificate later down the line, which is a pain. So when I actually sign the actual certificate, I've still got a reference back to this config file, which kind of makes sense in that I should really want to have the certificate signing request and the config file on my server. And in this case, the whole thing's a lot easier anyway, because I can actually do the certificate signing request and create the private key and sign the certificate all on one computer. So now that we've done that, and we've got our config file, the next thing is I'm going to copy over the actual command where we're actually going to sign this actual certificate signing request, because that's what you'd have to do. So we're issuing a request for basically a new certificate signing request. I'm pointing it to the key, which in this case is the test server key that we've actually created. Now, I want this to be using a message digest of SHA-256. I want the output sent to our testserver.csr file. So that's what that out parameter is. And I'm referencing it to the config file csr testserver-csr.conf that we've just created. So when I hit return, nothing comes back. The reason being is when we create that config file, there's an entry in there saying do not prompt. So it's not actually asking me for more details about the distinguished name, about organizational units, email addresses, and all that sort of conf. It's all contained within that config file anyway, so it makes life a bit easier. And the good news is that when this certificate actually expires, I can just keep referencing back to this same information going forward. Now, just to point out, And just to be clear, you don't actually have to have that there. I think it's somewhere down the line, I think browsers, or at least the vendors, were kind of hinting that they weren't going to be accepting certificates with private IP addresses. They want FQDNs, but you know, we've got flexibility entirely up to us. But what I want to do is, before I actually do anything with this actual certificate request, I can actually test it, because if I just look at that particular CSR, so if I just do say more CSR test server .csr, again it's just gobbledygook to me. It doesn't mean anything, but again I can actually read it, so I can actually get it to read in that CSR file. We don't want it outputting to a particular file. I want to read it in text format, but I'm going to pipe it out to grep, and I basically am asking it to add an extra line. So once it finds this entry subject alt, I want to see what the next line is. So rather than literally going through the whole certificate, I'm filtering it out. So if I hit return, you can see it's highlighted. There's a line in there saying subject alternative name, and it's giving me the actual details that's been included in the certificate signing request. So we've now got our certificate signing request, and what we'll now be able to do is to actually get to use this with our certificate actual authority server to create an actual signed certificate for the server. So now that we've actually got a certificate signing request for our server, the next step is to actually create an actual signed certificate that the server can use. So because we've actually just created that on this computer itself, we don't have to transfer it from one device to another. So it's just a case of running the command to actually generate that signed certificate. So I'm just going to copy this, and then we'll paste that into the command line here. So what we're doing is we're using the CA command within OpenSSL. So we want to use it as an actual certificate authority. We're telling it to use the root-ca.conf config file that we've got. So this has got all sorts of information that we need. So when it goes and checks that config file, it's going to be looking for a section called CA, for example, plus all the other sections that go with it. We don't want the output coming out in text format because we're creating an actual certificate. We also need to know what actual certificate signing request we're actually going to read in. So that's what the -in parameter is. It's referencing that certificate signing request. We also have to tell it where to actually create this actual signed certificate. So that's why we've got the -out parameter. So it's going to put that into the certs folder and create a file called testserver.crt. And then what we've got, because we've got these subject alternative names, we actually have to reference that config file again to be able to carry that information over from the CSR over to the actual certificate itself. It won't do that if we don't tell it about this information. You'll end up with a certificate file that doesn't actually include these subject alternative names. So here I've got a -ext file option, which is telling it to reference a file called testserver-csr.conf in the CSR folder. So that's the file that we actually use to create the CSR in the first place. And within there, we've got information about extensions that we wanted to use. So that's the req_ext section that's in that config file. So I'm going to hit return. Now, because all of the information about, for example, the private key is in that config file, the root-ca.config file, it already knew where to go. So now it's just prompting me for the actual passphrase, because we're protecting the root certificate key, not the server key, but we are protecting the actual root certificate key. So I need to type in the actual passphrase we used when we created that key. I'll hit return, and then it comes back and it's basically asking us for like one final check to say, are you sure you want to sign this certificate? So basically we're creating a certificate that's going to last for 10 years from 2021 to 2022. This is the distinguished name information, including test.templab.lan, which is the actual certificate, the FQDN, if you will, that server is going to present itself as, that will line up with the actual certificate. But you can also see it's also got the X509 details for our subject alternative name. In our case, we've got the FQDN information plus an IP address, but you don't necessarily need it. So basically, it's just going to be a certificate that lasts, I think I said 10 years, it's actually 1 year. But anyway, we're going to sign this. So let's select yes. And it's saying that there's one out of one certificate here being certified. Do you want to commit this? Effectively, it's asking you, do you want to update the database with this certificate? So let's say yes. So it's actually created a new entry in its database effectively. So if we do ls/certs, keep using the slash, it's just the certs folder. We've now got a certificate called testserver.crt. If we just do an ls-l, what you'll notice is this, that we've actually got some more files in here. We started off where we've just got an index file. What it's actually done is it's actually backed that file up, and it's created a file called index.old, for example. So that was the original empty file. And what it's done is it's then created a new index file with information about this certificate. So if I actually ask it what's in that index file now, you'll see we've actually got information telling us this is the serial number that was used for the certificate. The certificate's still valid. And this is the certificate that was created for a server called templab.lan. It's also actually used the serial key. It's actually backed the serial key up to the file serial.old. And what it's done is created a new serial key. So essentially it's just taken that. That was the original key, or serial number, if you will, that was used to create this one. So it took that from the serial file we originally had. Because if we look at that serial file now, you'll see all it's done is it's just incremented that by 1. And then that's going to be the serial that's used going forward. If I look at serial.old, you'll see that's the actual serial number that aligns with the serial that was used for this, to create this particular certificate that we've got here. So we've now got a key, and we've now got an actual certificate. So what we've got to do is actually get that information across to the actual server itself. So it all depends on the computer that you're using. For example, it could be a case of you might have an application, pfSense for example, where you can just copy and paste things in. I mean, this is private, like the private key, for example, it might ask for if you're starting from scratch, but it's a case of that's information you don't want to be out there. So you've got to be very, very careful when it comes to transporting this information. Now, for me, this is a root certificate server which is running OpenSSH. So what I can actually do is I can actually copy this information back to my computer, and then I can upload that information back to the actual certificate server. So what I can do is actually open up another session, for example. If we go into there, if I do, for example, SCP to copy the file, there's different ways you can do it, tell it to you, but this is one way. If we use the SCP command, I can actually say, I want to actually connect into that computer that we've got. So this is going to be, the user is CA admin, and it's going to be at 172.16.21.10. I want to reference that home folder for that user, and the CA folder. I want the certs folder within there. I think it's called testserver.key. I'll put the dot, and I want to copy it to just this folder here where I'm at the minute, for example. So we're basically just telling it to connect in through essentially through SSH, more or less, pull that file out and copy it back to us, because we've got OpenSSH running on that server, so it's something we should be able to do. So I'll just hit return. SCCP couldn't resolve the host name. All right, yes, okay. Let's type that. That should be at. So I'll hit return. So it wants to know what the password is. So it's saying no such file or directory. So let's see. So CA testserver.crt. What did we actually ask for? We actually asked for the key. That was my mistake. It should be CRT, because we're actually requesting the CRT file. Again, I've got to put in the password because each connection's unique, if you will, so we've always got to log in when we do it. And now it's actually copied the file across. So what I can then do is say, well, in that case, I want the actual private key as well, because I need both. Because we've created these on the actual certificate server itself, I'm going to have to copy them off and get these over to the actual server. I could have done some of this on the server. I could have created the key on there. I could have created the certificate signing request on the server, but you know, potato, potato. So this time we're going into the private folder and we're asking for the test server key. So I'll hit return. Again, I'm going to put my password in. And now it's copied those two files. So I've now got the two files that the server needs. But what I've now got to do is, well, first things first, I've actually got to get the computer up and running. And because that's running OpenSSH, I can actually transfer these two files across to that using exactly the same method. So we'll get that up and running, and then when we're ready to actually test this on the server, I'll bring you back. Well, I've copied across the private key plus the signed certificate across to the actual test server we're using. And I've reconfigured Apache to use them. So we're now connected to the web server through, in this case, Firefox. Now, the trouble is, well, we've got this big warning here saying potential security risk ahead. And it's basically, well, we've connected using HTTPS to test.templab.lan, which lines up with the certificate. If we click on the padlock, you can see it's broken, but if we click on the details, go to where it says connection not secure, we click on more information, then if we click on this, view certificate, it gives us the details, so you can see that it has actually loaded in the proper certificate that we wanted it to use. The only trouble is, even though this is not a self-signed certificate, our web browser here doesn't actually trust root CA, which is the issuer. So we know that we've created this certificate. We know it's not a self-signed certificate as such, but the browser still does not trust it. So we've actually got to reconfigure this web browser to trust the root certificate authority. So I'm going to go to settings, privacy and security. So I'm going to scroll down here and I'm going to start looking for where it is we put our details in. So security certificates. So interesting enough, Firefox does actually trust OCSP responders, but things like Brave don't, and that's basically the reason why I didn't go down this path of having multiple root servers, because normally I don't use Firefox. But anyway, in order to get this web browser to trust our root certificate authority, we've got to go into view certificates. Now, by default, interesting enough, it's automatically going to authority. So this is a list of all of the actual authorities that are out there, all the different certificate root servers out there that it trusts. So we've got to add ours in. So I'm going to click on import, and there's our root CA certificate there that I've copied across. So I'm going to click on open. Now it's saying, it's giving us options to what we want to trust this for. So technically I'm only interested in actual websites, but I'm going to select both, no particular reason not to. Click on OK, and it's now got this particular actual certificate in its list. Should be in there somewhere. Well, what I'm going to do is I'm going to just click on OK, because we've imported the certificate. If I click on refresh, there you go. You can see that the problem's gone away, and I do like that, I must admit. I didn't have to restart the browser or anything. If I click on this, it's showing you informations about that. If I click on the actual certificate, you can see that the connection's been verified by an issuer that is not recognized by Mozilla. So I'm still getting that slight warning because it's an internal certificate authority. But the fact remains is that we've now got a clean connection. So it's still secure in the sense that it's been verified by Templab, in other words, by us. So yeah, it's pretty easy to do. And it means that going forward, any certificate that I actually create and sign for any other web servers, any other devices that I've got in there, Firefox is going to trust it. The only thing to bear in mind is that if I've got an application, well, if it's relying on the operating system's certificate store, well, this is not going to help, because all we've done is updated Firefox, for example. But the beauty of it is that I've now got Firefox trusting that root certificate authority. So if I've got other servers out there, I mean, pfSense, for example, I could assign an actual certificate to that, for example. And if I connect to that through Firefox, because it's been signed by our templab certificate authority, Firefox already trusts it, in which case it will trust a certificate that's now been applied for the pfSense firewall. But I'll just close that. Close that down as well. If we go over to here, so this is Brave, for example. So this is the web browser I do prefer. Now, you can see we're connected in to testlab.land, so we've got this warning, oh, it's not secure. If we go to the certificate, it's saying the certificate's invalid. Again, it's referencing root CA was the actual issuer of the certificate. But the problem is that we've added in a trust for Firefox, but it's completely independent of our web browser here, this Brave web browser. So we've actually now got to update this web browser as well if I want to use it on this web browser. So again, I'm just going to go to settings on here. We'll go down to privacy and security. If we scroll down here, we'll go to security. And within here, there'll be an option for manage certificates. So if I click on here, if you notice, there's no option to trust certificate responders at all. I'm not seeing that anywhere within here to say trust OCSP, for example. It's just not there. So that's what's causing me the problems. But on here, by default, it just goes to your certificates. So I've got to go over to the authorities option. I've got to then click on import. Again, I want to import that root CA certificate. Now, this does give us a bit more options, so it's not just websites and email users. It'll even allow us to trust it for software makers, for example. So I'm just going to accept all of those. Click OK. Notice somewhere down in here we'll have an actual entry for org template down there. So for example, so it's giving the list of all the actual certificates it trusts. If we want to revoke this and actually delete this, for example, I'll go into the ellipsis here and just tell it to delete it, for example. Anyway, we'll close the actual settings. I'll click on refresh. Okay, that worked as well, so that's good. So again, I didn't have to actually restart the browser to get this to work. So again, we've got this nice clean connection where you can see an actual padlock here. So I'm not getting any warning about it being insecure. If you go over to, well, these sites are down anyway, so it doesn't really matter. But the padlock here is now closed. There's no warning coming up about this particular site. And tell you a bit, maybe if you go into a bit more details, you might get the same sort of warnings like Firefox did, saying that, well, technically you're coming in through a certificate that we can't necessarily vouch for on the internet. But in our case, it's happy as Larry, basically. Certificates, it is valid and so on, so it doesn't have any problems. You can dig into the details and so on. There is bits of information missing, like the organizational unit, because personally I'm not overly in need of that sort of thing. But again, it means that if I were to put a certificate on, well, actually if we go to our firewall, that's just complaining because it needs a resubmission. So if I go to the firewall, which is pfSense, you can see that one's complaining that it's not secure, and that's because this one is using a signed certificate, whereas this Apache server now, it's using a certificate that's been signed by our root certificate authority, in which case we trust the root certificate authority, so we're trusting this certificate that the actual Apache server is presenting. So it makes life a lot easier. So it would be a case of now, for me, for example, I'd go around to pfSense, update that. Any server that I've got out there that's got either it's a web server or it's a computer that I'm managing through a web browser interface, for example, it's presenting itself with its own little built-in web server, I can go around to that, update it with a private key and a new certificate. In the case of pfSense, for example, you could just generate the certificate based on the existing key and then send that over to the root certificate. It all varies depending on how you have to do it within that specific application, but the principle is basically the same. And what you end up with is this nice secure connection. And the really important thing about this is that going forward, once I've got all of my computers updated, I should expect to see that same response from any computer I connect to on my network. If I now connect to a computer and I see that, either the certificate has expired or something more serious has gone wrong, but that stands out. You look at that, I've got no issues with that. So if I go to there, straight away you can see that pops up in red. When you're using Firefox, it's like really in your face with that big banner. But that's the sort of thing I want to see, is this guarantee more or less that we're connected to the actual server that we expect to be connected to, not this. This is something I don't want to see even on my own internal network. So there you go. Not that difficult to configure and set up once you can wrap your head around it, I suppose. It is a bit fiddly in the sense that it's still a manual process. If you compare it to some of the automated systems out there, for example, where you can actually buy certificates, or you can actually install a software module on your computer that automatically goes out and connects and updates itself, that is a lot easier. On a test lab like this, no, that's not too bad. There's not that many servers that I'm connecting to through a web browser interface anyway, so it's not going to take me that much time to go around and update all of their certificates. So yeah, I quite like it in that respect, but it's a case of you just got to kind of get your head around it. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, because that encourages YouTube's algorithm to suggest it to other people who might find it useful as well. If you're new to the channel and you'd like to see more content like this, then yeah, do subscribe. Just remember to click the little bell icon though, that way you'll get notifications when I send new content out. If you've got any comments, any suggestions, if you want to leave any feedback at all, please post that in the comments section below. And if you'd like to support the channel, I've left links to both Patreon and PayPal in the description below. But above all, thanks very much for watching. I'll see you in the next video.